Hi everyone, so this is the lesson on inverse relations and functions. It is the last section that we're going to do in chapter 5. So this is section 5, 6, and this first page we're going to just take a look at is a lot of vocab, okay? So let's talk about relations, okay, and inverses. So here it says, what is the inverse of the relation represented in the table? So let's backtrack a little. What is a relation? Recall that a relation is any set of ordered pairs, x and y, where x is the independent variable and y is the dependent variable. It doesn't matter what these numbers are. It doesn't matter if they're positive or negative or doesn't matter what they are. A relation is really just a relationship between the x values and the y values, the inputs and the outputs, the independent variable and the dependent variable. Just a relationship. An inverse relation is formed when the roles of the independent and dependent variables are reversed, are flipped. So let's take a look at this table. Notice the relation here, x is -2, -1, 0, 1. In the inverse relation, these x's became the y's, -2, -1, 0, 1. In the relation, my y was 1, 4, 3, 1. In the inverse relation, my x is 1, 4, 3, 1. So that's key right here. An inverse relation, all that happens is when we flip the x and the y. The x and the y values are reversed. Let's talk about a function, okay? A function is a special type of relation where each input has exactly one output. So this table right here, it's totally different. Sometimes that's confusing. It's not related to these two. This new table right here does not represent a function. It does not represent a function because of these 2 points right here. Notice 1 goes to a y value of 1 and -2. A function, though, each input has to have a single output. The input of 1 has 2 types of outputs. It could be 1 or -2. That's why this is not a function, okay? And how we write an inverse function, it's this new notation. Anytime you see f to the -1, that -1 doesn't have any impacts on it mathematically. All that -1 means it stands for an inverse function. Okay, just like f of x stands for y, right? But let's say we took those y's and we flipped it and reversed it, and now it becomes an inverse function. That's where, well, it's still very similar to that original function, but it's the inverse of that function, and we write it as the inverse by just putting a little -1. Okay, I don't read that, though, as f to the -1 of x. I read this as the inverse function of f, okay? Not f to the -1. So let's take a look at some examples. How do we find an equation of an inverse relation? So when we look at tables, how we find the inverse relation, we just flip the x and y. That's all we do, and that's actually what we do when we're dealing with functions algebraically. All we do, there's 2 steps. Switch the roles of x and y, just like we would do in the table, and solve for y. So here's my first example. We're going to do f of x equals x squared. So obviously we have to first remember f of x is the same thing as y, because when we say switch the roles of x and y, well, maybe you'll get confused. Well, where's my y? Remember, f of x can be written as y. Then I literally switch x and y. So where I have y, I put x, and where I have x, I put y. So there's this step. And then I start to solve this for y. So how do I get this y alone? We have to go back to what we learned last chapter. How do I get rid of a square? We take the square root of both sides, and I'll get my y alone. So they just flipped it over here. Y equals the square root of x. Okay, I can also write this as f to the negative 1. Remember, the inverse function of f of x equals the square root of x. Okay, that notation shows, hey, these two are related, and the way they're related is that this is the inverse function of the original. And we're just going to take a look at another practice, and that's it. So here, I want to find the inverse function to f of x. Again, following two steps. First step is switch the x and the y. We can put that y in for f of x if you want to. Makes it easier to switch. So now where I have a y written, we're going to write x, and where I have the x, I'm going to put the y. Then I just have to focus on this y and solve it. So how do I get this square root? How do I get rid of that square root? Because I have to get rid of that square root in order for me to touch that y. In order to get rid of a square root, we square both sides, right? So now we'll have x squared equals y minus 2, right? And now how do I move that 2? I'm going to add the 2 to both sides. Add 2 to both sides. And we will have x squared plus 2 equals y. My y is alone, and I can write this a little bit better, saying the inverse function of x equals x squared plus 2. Like, that means these two are related, and how they're related is their inverse functions. Okay, so you have to really work from the outside in. So anytime you have a radical, that's probably going to be your first step. Square both sides to get rid of that radical. Then you can play around with whatever was under the radical. So just practice some of this stuff, guys. Awesome job. We're done chapter 5.